Everybody finds a method of pre-planning or coming up with their design that they feel comfortable with. And I am definitely more on the design side than making plans side. Yes, I will take certain critical measurements. If I'm building a table, it's got to be a certain length, a certain height to be comfortable. Or a cabinet might need to fit in a certain space. In this application, I just need to fit the components into my contraption of whatever it is. So those are really the only measurements I actually do here. Everything else is based upon the size and, more importantly, the order I build my project in. I spend a lot of my pre-thinking time not only thinking about the joinery, what I want it to look like, but the sequence of events in the build, so that I can build these things based upon the size of the other components. It's kind of relative to the next step. And from there, I like to go to my whiteboard because it's big and it's easy to erase stuff and I can make a lot of messes. And I might throw up a couple different plans. I mean, each one only takes a few minutes to think through. From there, I'll come up with a design I really do like, and I'll put it in my design book. And I'll really think it out, draw the joinery, all that kind of stuff to make sure at the end I'm going to be happy with the way it looks. Now, it's a common theme in my shop that I'm going to use solid wood, mainly southern yellow pine, because it's construction lumber and it's the cheapest solid material you can get. And while it is construction lumber, you can get nice straight quarter sawn or bastard sawn grain, just depending upon how you select the wood, making sure you have straight grain from the store. I don't really worry about cupping too much because I'm going to be processing it just as if I had bought 6/4 material from a lumber yard. The key thing is, I like to buy stuff as close to the center of the tree as possible and then just cut out that center because it might have some cracking in it. That's where most of your cupping is going to come from. It's the outside of that that's going to be so stable. And a lot of people, they make comments that, why are you wasting time using solid wood for, a shop appliance? I mean, this is just going to be beat up and destroyed. And I keep coming back to this idea that I want to learn. I enjoy this craft. And what better low-risk project is there to learn on than shop equipment? Now, in this build, I want to revisit some old joinery that I did. You could see a good example of it in my Build a Table in a Day video. But I also want to try some new techniques in tool setup, tool layout, processing and stuff that I can compare and contrast on what I know I can do. It's going to end up in the same way. I mean, there's 3 or 4 ways you can cut any kind of joint. But this gives me the chance to practice and learn. Where else is that going to happen? And that to me is a mentality that if you're not a high production woodworker, you've got to take. Yes, the project might take you a little bit longer to complete, but in the end, you're going to gain a lot more from it that you can apply to the more important stuff, the stuff you want to sell, the stuff you want to give to your family, the stuff you're actually going to be proud of. This is just a learning opportunity, and it's going to make something that will get the job done. On project this size, I tend to mill up the material for whatever section I'm working on. And that generally starts at the jointer and progresses to whatever mate that is. So if I did an edge, I'd go to the table saw, and that makes those 2 sides parallel. If I did a face, I'd then go to the thickness planer, and that would make those 2 sides parallel. Technically, you're supposed to start out on the face, but this was flat enough to begin with there. And the reason why I do it per section is because, remember, I build to a design, not plans. I'm not really concerned with getting perfect measurements unless it's critical for the overall project. I just want each sections to be consistent. So all my base being the same, all my legs being the same thickness. That way everything's just very easy to level out. Plus, milling up only what you're going to be using in the section that you're able to finish building in a certain time frame kind of gives you a sense of completion. You've done that step. For example, right here, I'm starting on building the base frame for the entire project. And because they are all consistent, I can take my measurements directly from the piece, totally ignoring the ruler. And right here, I'm just taking the width so that I can get the depth of a bridle joint. And this entire project is going to be using lap joints, bridle joints, and finger joints. As I mentioned earlier, I'm revisiting old joints that I know how to cut, but experimenting with new techniques. Here I'm cutting out the faces on what's going to end up as a bridle joint. And all I did was I made sure that my bandsaw was at 90 degrees, used my marking gauge to take the width of the board and mark it out for the depth of the cut, and then just eyeballed a third. As long as I flipped the board, those two cuts would be centered. I can then take that baseline that I marked out with the marking gauge, go to my table saw, and eyeball where to cut the end. From there, I can take the piece I actually cut out and just move my fence over on the bandsaw a tad bit in order to compensate for its curve. How did I do that? I literally used my finger as I moved the fence back and forth until I got the curve at the exact right spot. And then it's just a matter of sawing and flipping to remove the center section. Notice because I set the fence up so I could cut on the far side instead of the near side, that allowed me room that I could cut down the middle in order to remove the waste and simply curve it a little bit to cut out each side. Flip it, you cut out the other side, and in essence, I'm using the bandsaw just as I would a coping saw and the hand tool roll to get rid of the majority of the waste so I could then chisel it down to the baseline and get a perfect interior face for this bridle joint. And I hope that's something you notice throughout the rest of this video, that the techniques I'm experimenting with and practicing with is using power tools much in the way I use a hand tool. And most of the time, it's making the settings on the machines based off the dimensions of the other parts, just as it would be using my fingers on a handsaw when making a cut. When you work this way, it's amazing how little cleanup there is, because just like when you're using hand tools, basically you're splitting a line, taking a line, leaving a line. So most of the time, that just leaves you a tad bit to flush two parts together. At this point, I added the casters supplied by Rockler because their screws would be a further reinforcement of the joints in the corner. Then it was a matter of returning to the bandsaw, the miter saw, the jointer, the table saw, and the thickness planer to mill up all the material I would use to create the eye joint or the cross beam on this base frame. Except instead of using a bridle joint, I would use a finger joint this time. All the same techniques, all the same tools, except this time it's all done on the face instead of the edge. The one difference being on one of the short edges, I cut off the distance of one of the fingers and then used a nail and a ruler to create an arc that came down to the height of the bottom finger. That way it would be flush in a future step. I then smoothed it out and made the curve nice using some spoke shapes. I will say later on down the road I reversed this section because I didn't like how it was turning out. It wasn't working the way I wanted to, but we'll get to that later. Now gluing and attaching this frame to the base is critical for the entire design because having the glued and screwed together will create a very strong frame that can handle a lot of weight. It's basically a portion of an I-beam. It'll also give a lot of face value for glue and screws to attach the upper carcass. Now to attach those screws, I placed the frame on there, drew the pencil line in the center so that I would know where it would go back once everything's aligned. Then I spent 30 seconds and created a quick screwing jig, something that would tell me where the exact center of the board would be, and I didn't have to do more layout lines. Then it was just a matter of laying down a bead of glue and screwing it down using the screws as both clamps and reinforcements to add strength. And please notice that I screwed the opposite corners first. This just reduced the chance that it might shift while I was screwing all the way around, which happens a lot of times if you go clockwise or counterclockwise in order. Now after that, it was just a little cosmetic touch-ups, because once I was done with this, I was going to be done with it. That's the advantage of building in sections, designing in sections. So I just wanted to do a little bit of make pretty, round over edges and stuff like that. Unfortunately, I trusted a ruler at some point in time. So when I went to test out the barrel, I found out it was a 1/4 inch too small. I'm not sure where the error was. I shouldn't have used a ruler at all in the beginning. I should just take measurements directly off of placing boards on the side. But live and learn. Either way, I had to make a quick fix. And to do so, I was just going to take advantage of the weakness of the wood, something you do over and over and over. Simply by separating the fibers in multiple areas, it would make it really easy to chop out the waste going with the grain. You're basically splitting off what you don't need and then cleaning it up with a gouge, a chisel, or sandpaper. Now to create the slats for the barrel to rest on, I went back to that center section that I cut out of all those boards that was basically scrap and dimensioned them down to about 1 inch, just enough that they would sit flush with the bed. And then I could screw them into that integrated rail that I created by placing that I-beam portion in the middle with some overlap on both sides. The outside basically created a bumper, and the inside created the ledge that's going to transfer all the weight of this entire contraption down to the wheels in an orderly manner. Now, even though these scrap pieces were all different sizes, I wanted them to look orderly. So I used a speed square to create spacing in between them, and I used my dividers to create an equal distance between the screws. After that, it was back to the machines to dimension more lumber to start on the uprights. And I took particular care to balance the grain on these uprights so that they would look good. They would look like they were out of a solid piece, but they're actually going to be mitered. I cut a 45 on the long side of all the boards so that when I glued them together, they would form an L. Now, gluing these together was a little bit difficult for me because I don't have any clamps that would work this way, but I do have gravity. And simply lifting them up, placing glue down on them, and letting gravity spread the boards out until a certain point, and then using my clamps to stop it at that point, will allow me to get a good face-to-face surface glue bond. Was it perfectly gap-free? No, but it's good enough for what we were doing here. And on the one board that I saw a gap right from the get-go in the gluing, I simply held them together with my hands for about 2 minutes, and that was good enough. Set the rest of it aside for 5 minutes, take it out of that clamp for an hour or so, and then continue work. Now the key to these uprights really being secure and transferring all the weight that they're going to be carrying down to the frame is the half lap. And you can't trust a ruler when you're marking these out. Go ahead and take it directly off of the piece. That way, all you have to do is line up your saw blade so it leaves the line. It doesn't take it away. And then bandsaw off those cheeks. It should be able to rest perfectly on both the ledge and the upright. And once you got that set, do all the legs the same way. Except for the two fronts. On those, I only did a lap joint on one side, and you'll see why later on. From there, we're going to progress to an upper and center frame. And the combination of a top, middle, and bottom frame for the uprights will create an incredibly strong tower that should be able to hold all the weight of the machinery and the Cyclone, because that middle frame will be cantilevered to hold the weight up of the Cyclone itself. But because I don't want to mess with rulers, I'm just going to take the measurements directly off of the piece, making sure that both the middle and the upright, the short sections, are all the same size, and that the long sections, only the middle ones, are going to cantilever off. Oh, and as you go along, don't forget to pick out which side of every board is going to be your show side. And once I've gotten to this middle and upper frames, it's getting more critical that I get the exact corners right. So I'll go ahead and label them. Why is this? It's because it determines which is going to have end grain and long grain showing, and you'll understand that in a few seconds. But by simply taking off the measurements directly from the pieces, it sure does make the tool setup quite easily. Since I cut out that central finger by flipping the bandsaw from one to the other so it was equal distance, I really only had to mark one of them in order to set the bandsaw up to take the corresponding fingers. I really am finding in this project using hand tool techniques with the power tools really sped me up, especially because I'm only building one project. I'm not setting jigs up to repeat the same cuts over and over and over again. It's that mark a line, solder the line, hand tool mentality. That's nowhere more important than when you see me do this central mortise and tenon joint. This is the hand tool method. I laid it out to where I want it to be. I marked a quick 90-degree reference, and then using this piece of stock that's going to go through the board itself, line everything up. I got one side, put my knife down on the other side, and guess what I have? I now have that perfect measurement for the mortise fitted to the tenon. Now it's just a matter of transferring it around to the other side, which a nick on one corner allows me to do. To find the width of it, or the height of it, pencil line right off the piece. Can't get easier than that. Hand tool techniques a lot of times comes down to simply laying stuff out in a slightly different manner. There is no need to use a ruler if you don't have to. Now to cut out the mortise, I like to use my chisel to break the fibers all the way around, especially in pine like this. If I don't do that one, I find a good tendency that it will chip out on the pretty stuff I want to keep. From there, it's just a matter of removing the material. It's quite easy to do that one if I drill a small hole in the corners, because it's always the corners that I have difficult with. And I'll drill halfway down from each side, and then it's a matter of using the chisel. The bevel is the direction you want to go, and if you notice, the first strike doesn't go down too far, but each subsequent strike goes down a little bit farther. That's because the wood now has an escape path. On the first strike, all you're really doing is compressing the fibers. On the second strike, it can ride that bevel down, kind of like a ramp, but the wood now has a place to go. So you can go deeper and deeper and deeper each time. And that last strike, basically, you're compressing the fibers, making a space for the next pass to go deeper. Do that one for both sides, and then clean up the edges, and you have your nice hand tool mortise. Really is pretty simple and quick, especially because you don't have machine setups. With that center cantilever frame built, now it's just a matter of transferring a mark on where I want it on the uprights. And I wanted it in line with the top of the canister, the top of the barrel, except maybe an inch higher. From there, it's just the same process, except instead of using a lot of cuts for the dado, I just ran it over my table saw blade quite a bit, a little bit low, and then used my router plane to make it dead on level perfect. It didn't have to be perfectly flat in that section, because that is going to be inside the wood, and nobody but Superman has X-ray vision. Last step on these uprights was to add a groove so I could put some panels in there to hide the motor and, most importantly, contain all its noise. Now to finish up the central stack, I had to add panels into it. And to do that one, I just used up the last of the scrap, the part of the boards that I couldn't have used for anything structural because they might warp or twist or something like that. I cut them in half and then planed them all down to whatever thickness would fit in the grooves I put on that board. On the first one, I glued the bottom and left it at 90 degrees. All the other subsequent boards, I cut at half of 45, I guess it's 22.5 degrees, and left a gap in between each one of the boards as I attached them in there. I put a little glue on one end, dropped a bunch of rulers down there to create a consistent gap, and then nailed the top to act as a clamp until that wood dried. This way the wood could expand and contract, be anchored by the glue, but the nail would kind of wiggle around. The end result is I had these panels with a small gap but because of the angle I cut, you couldn't see through them to the inside. Light wouldn't show through. And it used up that cathedral grade scrap wood I had. Once I finished the top half of the panels, I attached the top frame, glued and screwed it down, then picked up the whole thing so that I could do the bottom half. Notice on the top, I did leave one side open, because that's where I'm going to install a door for easy access to the on-off button and to be able to empty the bag every year or two. Now it's starting to look like something, doesn't it? Well, in order to block a little bit more sound, I did want to line the interior with something. I had some thick cardboard on hand, so instead of using the pink stuff from the big box store, I was going to try this. Staples will hold it in, and on top of that, on one side, I cut down an OSB sheet, and that will be what holds up the motor on the interior. I did have to remove the handle on the motor in order to make it fit, and unfortunately the screws that they use to attach a handle go into the body. So if you leave the screws out, there's a hole. That's going to be a vacuum leak. If you leave them in, there's a chance that the screws could screw themselves in through with vibration and hit the impeller. So my solution was to put the screws back in, but put some hot glue on the outside. So hopefully that will prevent them from screwing themselves in. Well, I mentioned earlier in the video that I was going to end up changing that low curved upright piece on the base. And it was just that I didn't like the setup I had for raising and lowering the canister up to the dust Cyclone. So what I ended up doing is switching to a simple panel, which means I had to remove that curved one front section. It was a really simple job. Just saw off the joint, and because I didn't have that much glue, and I thought that this might happen, so I didn't screw this front section down, it just popped right off along the glue line, and I could use a card scraper to sand it out. This also meant I needed to extend that cutout I did because of that original mismeasurement somewhere. But this was really super easy. Simple saw cut to establish the line and chisel off what I didn't really need. No big deal. The last step for the main tower was cutting a hole for the dust hose. And I'd simply drilled a hole right in the center of where it was, and using this pair of dividers marked out a hole that was a little bit more than 4 inches. Remember, when you're using dividers, always rotate them in a manner where the grain will push the legs out, because in some directions it will actually want to compress them, thus making your circle a little bit off. From there I just made a little 4-inch cutout and used my router with a flush trim bit to get a perfect little over 4-inch hole. Now the last 2 wooden parts I needed to make for this was the top and the door, and both of those I just did a bridle joint with the same waste wood panel in the middle. But I gotta admit, I kind of reverted to my old ways. I didn't want to spend time setting up a router table, so I just really quickly grabbed my router plane to put the groove in all of them. But when you work this way, you got to take into consideration that you made a groove through the whole board on all 4 pieces of either the panel or the door, meaning there is a cutout. Now, assuming a bridle joint has one board that's the tenons and one board that's a mortise, the tenons are going to be the exact same. Just use the width of the board. But the mortise, you got to use the width of the board minus that groove. That way you'll get a nice smooth fit. From there, I just put some little cleats on the top, and I used hide glue to attach it. Just in case I ever want to replace this motor or upgrade it, I can heat it up to remove it. And on the door, I put a simple swivel latch. No big deal. Just using up scraps, and I didn't want to pay for a metal one. Well, I hope you enjoyed this video. If you did, please like, favorite, subscribe, do all those social medias. Visit my website, wortheffort.com, where I have lots of different ways you can help support us. And I want you to remember one last thing. On builds like this, it is always worth the effort to learn as you create, so you can share with others. Y'all be safe and have fun.